So in the last section, we solved systems of equations involving two equations and two variables. In section 7.2, we're going to solve systems that have three equations and three variables. Geometrically, what these are planes, not airplanes, but planes in space. And so planes can intersect in different ways. So let's see how this is going to go. So the process is elimination. It's essentially the same thing we did in the last section. Now we just have an extra variable. So step one, we've got 3x plus 9y plus 6z is 3. 2x plus y minus z is 2. X plus y plus z is 2. First thing, identify the equations that have the variables that are going to provide you the least amount of resistance. So you can cancel the x's or the y's or the z's. It absolutely does not matter. You will end up in the same place. But what I'm going to notice here is if I just add these two equations together, the z's fall out right away. So what I'm going to do is I'm going to eliminate the z's. So I'm going to take these two equations right here. I'm going to eliminate the z's. So when I add them together, 2x plus x is 3x. Y plus y is 2y. And then negative z plus z, those cancel. That's great. And then that's equal to 2 plus 2 is 4. So now what I want to do is I'm going to pick a different pair of equations. So I can either pick the top and the middle, or I can pick the top and the bottom, since I already used the middle and the bottom. And I'm going to eliminate the z's in that one. Now that I've eliminated the z's, I have to do the same thing in the next one. So I'm just going to use the top and the bottom, or excuse me, the top and the middle. I'm going to eliminate the z's. So I notice I have a 6z here. I have a negative 1z here. So what that means is for me to eliminate the z's, what I'm going to do is I'm going to multiply this equation right here by 6. What that's going to give me is a negative 6z here to go along with the positive 6z right here. Those will cancel. So here we go. I've got my top equation, my 3x plus 9y plus 6z equals 3. That is not changing. Then my next one, 6 times 2 is 12x. 6 times 1 is 6y. 6 times negative z is negative 6z is equal to 6 times 2 is 12. And now when I go ahead and add those two things together, 3x and 12x, that is 15x. 9y and 6y is 15y, and then the z's cancel like I was hoping, and 3 and 12 is 15. Now that's just coincidental that all those coefficients are the same just for this problem. At this point now, you have the exact same situation that you already know how to solve from the previous section. I've got two equations with two variables. Now I'm going to eliminate either the x's or the y's. To me, it looks like the x's are going to be a little easier. I can multiply this top equation by a negative 5. That'll give me negative 15 here and positive 15. Again, you can multiply, you can eliminate the y's if you are so inclined. So I'm going to multiply there by negative 5. And so what I get is 3x times negative 5 is negative 15x. Negative 5 times 2 is negative 10y. And then negative 5 times 4 is negative 20. The bottom equation I am not doing anything with. And now when I add everything together, I get negative 15x plus 15x. Those cancel. Negative 10y plus 15y is 5y, and then negative 20 plus 15 is negative 5. And then last but not least, I'm going to divide both sides by 5, and I get my first part of my answer. Y is negative 1. Now I just work my way back because remember, we are in space now. We've got three variables, so I'm going to have what's called an ordered triple. There's always an x, a y, and a z. It's alphabetical order that way. So I've got the y value. Now I'm going to go back here to the middle where I have the two equations and two variables. I'm going to pick one of them. It does not matter at all to figure out the next. So I'm going to take the y as negative 1, and I'm going to put it in right here. So I have 3x plus 2 times negative 1 equals 4. That's 3x minus 2 equals 4. When I add the 2 over, I get 3x equals 6. Divide by 3, and x is equal to 2. So I've got my y value. I've got my x value. All that remains is I go back to the very beginning. I pick any one of those equations. It does not matter. I'm just going to use this bottom equation. And here we go. I've got x. My x value is 2 plus y. My y value is negative 1 plus z is equal to 2. 2 plus negative 1 is 1. When I subtract 1 from both sides, I get z is 1. And so here is how you write your answer for a system of equations that have 3 variables. It's an ordered triple. So again, I'm going to use a squiggly. And then my x value always comes first, so 2, comma, my y value comes next, comma, my z value is last. And x, y, z, that is always the order. And that is the solution to this system.